All right, we are continuing our study of statistics. We are in section 1.8. The last section that we did was looking at frequency tables. We learned that if you have a bunch of information, sometimes it's easiest, most times it's easiest to make a table. We were looking at two-way tables. So on the start thinking part, it says the following two-way tables represent the results. Two groups of people are interviewed to find out what their highest level of education is. So you have group 1 and you have group 2. Now we're trying to look at these and figure out the answers to our questions. The first question is what group had the higher concentration of people with bachelor's degrees? So the first group, when you add together all the ones with bachelor's degrees, it looks like it is 75. And in the second one, it's 64. So initially, it looks like group 1 is going to be the one that has the higher concentration. But there is this word concentration. It's kind of like if you add a can of soda and it had sugar in it, and then you got 10 pounds of sugar and poured it into a pool, and you said which one has the higher concentration, it is probably going to be the can of soda, even though there's much less soda and much less sugar. When you have those two things together, the concentration is going to be more. So when we're looking at these, one of the groups had a total of 142 people interviewed, and the other one had 120. So it's not apples to apples, meaning you can't just look at the total number of people with bachelor's degrees in each one of those groups. So what you actually need to do is find them as a percent, and that's what the students did. And when you look at it, group 1 has 52 point something percent bachelor's degrees, and the other one had 53%. So it's group 2. Even though group 1 had more people with bachelor's degrees, the concentration is more when you're looking at it as a percent for group 2. The next one is which group had a higher concentration of males. When you're looking at this, the first group had 70 males, the second one had 62 males. So once again, it seems like group 1. When you look at it as a percent, you find out that the second group, once again, had more. And then lastly, which one had the higher concentration of females with master's degrees? Females with master's degrees was 22 for group 1, and the other one was 20. Once again, it looks like group 1 is going to have more, but when you look at it as a percent, it's 15% versus 16%, and it is close again, but it is going to be group 2. So the main thing here is when you're looking at two different frequency tables, unless they have the same exact number of interviewed people or total amount of people that you're looking at or data points, it's just really hard to make sense of it and try to compare the two. So what we're going to do now is look, rather than looking at frequency tables with just raw numbers, we're going to be converting those into percents. And when you convert something into a percent, it does not matter how many total there were for each one of the groups. It becomes a percent per 100, and it makes it easier to compare. So when we're looking at the next application, it says several students are interviewed to determine if they eat candy, that's supposed to say candy, regularly, and if they had a cavity in the past year. The results are recorded in the two tables. Determine how the percentages were calculated. And you're also going to be answering these questions 1, 2, and 3. So question number 1 says, what does the 32% mean for the problem? And you can see that is the intersection of had a cavity and eats candy. So 32% of the people had a cavity and they ate candy. So there we go. The next question is, how was that 32% calculated? Well, we can see in the normal frequency box, there is a 16 there, the one on the left. How did 16 become 32? Well, it was 16 out of the 50 total. So 16 divided by 50, and that is the number of people who eat candy and had a cavity. That is 16 out of the total, which is 50, ended up being 32%. The next one says, 32 plus 12 plus 16 plus 40 equals 100. What does this mean for the problem? That is saying that every single person can be categorized as had a cavity and eats candy, had a cavity, doesn't eat candy, no cavity and eats candy, and no cavity and no candy. So when you add all those things up, it is going to account for everybody, which is 100%. So this is what we're going to be looking at. Now, the only funky thing here is you can make multiple different relative frequency tables here. So this one was looking at the numbers and comparing them to the total. Now I could have said, out of the kids who had a cavity, what percent ate candy? Now it wouldn't be the 16 divided by 50, it'd be the 16 divided by 24, because the only thing we were supposed to be looking at is had a cavity. If they had a cavity, what percent eat candy? That would be 16 out of 24. Same thing if I went over and said, out of the people who ate candy, how many did not have a cavity? Now it's not going to be 6 divided by 50 because 50 is not the total people who eat candy. The total is 22. So we talk about these as rows and columns. The up and down ones are columns and the left and right are rows. The way you can remember this is if you're in a boat and you are rowing, your oars are going to go left and right. So the rows are left and right and the columns are up and down. The columns in Greece are up and down. So let's look at this idea of the fact that you can have multiple frequency tables with the same information. So on this one, you have the normal frequency table, which has the raw numbers in here. That is the top left one. So this is talking about people, if they prefer cats or dogs, and if they are urban livers, they live in an urban area, or if they live in a rural area. So 54, in this case, would live in an urban area and like cats. 80 would live in an urban area and like dogs. So you have these, just the numbers out of the total 200 people interviewed. Now the first one is saying how many people who are urban also like cats out of the total. So this first group here is talking about the numbers out of the total. So 54 is what percent of the total 200, 42 is what percent of the total 200, 80 is what percent of the total 200, and you do that. That is what this first one is. Now the next one is talking about the columns. So this one is saying out of the urban people, what percent like cats and what percent like dogs? Out of the rural, what percent like cats and what percent like dogs? So the way we got that was the 54 divided by 134 and the 80 divided by 134, because the total is now just the people who live in the urban areas, or the other ones would be divided by 66, because those are the total people that live in the rural. Now, table number 3 is saying out of the people who liked cats, what percentage lived in the urban and which percent lived in the rural. So the total is the percent, or are the total number of people who liked cats or who liked dogs. So you're dividing by a different number here. So you have these 3. Now, question number 1 says, for each relative frequency table, select a percentage and explain what that number, or how numbers from the original table were used to get this. So I went over and said in T1, the 27 is going to be the 54 divided by the total. So 54 divided by 200 gets your 27%. For graph number 2, or the table number 2, I called it T2, the 40% would be the total number of people who are urban and like cats, which is 54, divided by the total urban, because this is the one where we were talking about out of the people who are urban, what percent like cats or dogs, or out of the people who live in the rural areas, what percent like cats or dogs. So that is how we did that one. That one would be, for the 40%, that would be the 54 divided by the 134. And then for our last one, I picked the 56. The 56, you had a 54 in that location for the normal frequency table. And this one is going to be the 54 divided by the 96, because in this case, we're looking at the rows. So the totals are totaled up on the rows. So it would be the 96 and the 104 that we would care about. Now it says, what percent of those surveyed live in an urban area and prefer dogs? So this is the total people that we have interviewed. So that is going to be T1. T1 is going to be helpful for that. And they live in an urban area and prefer dogs. That's the 40% one. The next one says, among people surveyed who prefer dogs, what percent of them live in urban settings? That is T3. T3 is the one where we were looking out of the total of people who like cats and total people who like dogs. So it said, out of the people who like dogs, what percentage of them live in an urban area? That's 77%. The next one is, what percent of people surveyed who live in an urban setting prefer dogs? The one that was totaling up the urban and the rural was T2. And then it says the percentage of people surveyed who live in an urban area and like dogs, urban and dogs, is 60%. The next one says how many, not what is the percentage, but how many people responded that they prefer dogs and live in an urban area. So when we look at that, that is out of all of them surveyed. So that's T1. And T1 says it's 40%. 40% of the total, which is 200, gets you 80. And then last, no, we got 2 more actually. It says among the people who surveyed, that is all of them, are there more people who preferred dogs or cats? So we can actually look at the general one that is just raw numbers. And when we look at that, Preferred cats is 96, preferred dogs is 104. So that would be dogs. Or you could look at the percentage one for T1. And the last one says, your pet food company has access to a billboard in a rural setting. Would you recommend that they advertise dog food or cat food? And it would be cat food because it shows that 64% of people in the rural areas from T2 preferred cats. Now let's take a peek at your homework. On this first one, it says a teacher asks students whether they studied for a quiz, then she scores the quiz. A relative frequency table displays some of the information they have collected. What does the 86% mean? Now, my original thought, as you can see, I had to change my answer, was that it means that 86% studied and passed the quiz. And I started looking at it, and I'm like, this doesn't make any sense because 86 plus 14 plus 46 plus 54 is more than 100%. So this can't be a percent of the total. That makes no sense. So then I started looking, and you can see that the rows add up to be 100%. The columns do not add up to be 100%. So what that means is out of the kids who passed the test, 86% studied. The way that I knew it was not a percentage of the total was because all of them did not add up to be 100%. The way that I knew it wasn't saying out of the people who studied, how many passed the quiz was because the vertical ones don't add to be 100. It's the horizontal ones that add to be 100. And that's a nice way to be able to figure out how they're doing it. Do all of them add up to be 100? Are they the rows that add up to be 100? Or is it the columns that add up to be 100? Now this next one right here, when we're looking at this, and we had to make our relative frequency chart. This says the accessories choices of 143 people are recorded in the table. You have all those. Create a relative frequency table that could be used to show the percentages of belt wearers who wear a watch or not, as well as the percentages of people without belts who wear a watch or not. Now you can see that I was doing the totals that were the horizontal ones. And the reason why is because it was talking about out of the ones that wear a belt and out of the ones that don't wear a belt. So those are the totals. We're not looking at total all together. And that's how I got the 66 and 34%, which adds to be 100, and 59 and 41, which adds to be 100. Because I was looking at those numbers divided by the total in each row. You got to look at the wording there. Now, the next one says scientists give two different treatments to people who have the flu and determine if their health improves. The results for the test are in the two-way table below. What percentage of people received one treatment and had improved health? When we're looking at this, had one treatment and improved health. So when we look at that, you have the 23, and it is going to be 23 divided by the total people that did treatment one, which was 40. So 23 divided by the 40 gets you your 58%. And the next one is what percentage of people receiving treatment two had improved health. So out of the people who got treatment two, which is a total of 60, it says 25 of them had improved health. So 25 divided by 60 gets you your 42%. That's how you get your 42%. You got to look at the wording to figure out if you're dividing by the total or if you're dividing by the rows or the columns. Let's keep on going here. On this next one right here, it's trying to figure out what is the value that could go in here so that which could go in the blank so that the percentage of only children that have no pets is 37.5%. So we're only looking at the only children part. So what I do is I just tested them out. I said 105 plus 63 divided by the total, which is 105 plus 63, because we're only looking at that column. And that did get us 37.5. So that is why A is the correct answer. And for our last one here, it says many adults are selected at random to respond to a survey about their favorite season and whether they have allergies or not. The two-way table summarizes the results. Which season is the least popular? When we look at this, the least popular, if you add these up, would be spring. So when you take a look at spring and you add those together, you end up getting, let's see, 64. 64. And when you add up all the rest of them, sorry, no, spring is 12 and 13, which is going to be 25. And when you add up the rest of them, you find out that they're all more than that. So spring is the least popular. How many people have allergies? How many more people have allergies than people without allergies? So you can go over and add up all the allergies ones, add up all the no allergies and subtract them, and you get 21. And how many people were surveyed in this group? If you add them all together, you get 225. All right, hopefully that made sense. Thanks for watching.